So now that we know what solutions can look like, we can go ahead and start solving. And so we are going to solve by elimination, like we have discussed. And we need to follow our steps. So the first step, notice, it says to arrange the equations in columns. So notice if you look at my columns, here I have my x's, I have my y's, and I have my numbers. Notice also though, my equal signs are stacked nicely too. So everything is in a nice, neat column. So I'm good with step number 1. Step 2 says to look at the coefficients to make a wise step. Because we need to find opposites. We're looking to make opposites for step 3. So we have the coefficients 8 and 5. We also have a 2 and -1. Now I need to make opposite coefficients. So I'm going to go with the ones that are already opposites. I'm going to look at the y's. So I have a 2y and I have a -1y. Well, they're already opposite numbers at least, but they need to be exact opposites. So I need to multiply the second equation by something to make it a -2y. And so -1 times 2 should give me that -2y. So this first equation is still going to be 8x plus 2y equals 16. Now when I multiply it by 2 to the second equation, I have to multiply every single term by 2. And I get 2 times 5x, which is a 10x, minus 2 times 1. So, minus 2y, that looks really nice. And then 2 times 28, which is 56. So if you look here, notice my y's have opposite coefficients on them. And so that's right there was number 3, or step 3, which I just completed. So we can go ahead and move on to step 4, where we add our equations together and solve for the remaining variable. So if I add these together, I have 8x plus 10x, which is 18x. Then what happens here with these opposite coefficients, 2y minus 2y is 0y. It completely cancels, which is super convenient for us. And then 16 plus 56, we get 6 plus 6 is 12. Carry the 1, 5, 6, 72. And then we need to solve for the variable, because notice right here, we only have x's. We got rid of all our y's. So we can divide by 18 on both sides, and x equals 4. We have half of our work is complete. Now, moving forward, we need to look at step number 5. Step 5 says to substitute the value for the variable that you solved for, so this x equals 4, we need to substitute that into either of the other equations to solve for the other variable. So I'm going to plug it into this first equation up here. So it was 8x plus 2y equals 16. Now I know x is 4, so I can say it's 8 times 4 plus 2y equals 16. 8 times 4 is 32. 2y equals 16. Minus 32 on both sides. And 2y equals minus 16. Divide by 2. And y equals a -8. And so right there, we found our value for the y's. Y equals -8. Now, before we can write our final answer as an ordered pair, which we think is going to be 4, -8, but we're rather confident, we have to check our solution. So, take our original equations, plug in 4 and -8, and see if we did it correctly. 8 times 4 plus 2 times -8. We get 32 minus 16. Yes, it does equal 16. 5 times 4 minus negative 8. We get 20 plus 8, which, yes, it is 28. And so we did solve correctly with our answer checked out. And our final solution would be 4, negative 8. So what I want you to do with this next problem is we're going to solve by elimination again, but I want you to go ahead and try it on your own. Notice they're already arranged, and notice we already have opposite coefficients. So actually steps 1 through 3 are conveniently already done for us. Because right here, we have a positive x and a negative x. So we have those opposite coefficients. So we can actually start way down on step 4, where we add them together. We'll find y in this case, substitute it back in to find x, and then check your answer. So go ahead, give it a try, and come back and check your work. And so looking at our work here, we had opposites. So we went right ahead and we added our equations together. And in doing so, x's disappeared. So we had 3y equals 24. Notice at this stage, only one variable, so we did it correctly. And that, when we solve, gives us a y equals 8. We then took our top equation, plugged in 8 for y, solved for x, where we got x equals 8 also. And then from there, we had to go ahead and check our answer. Because even though we got the solution 8 equals 8, 8, we need to make sure that we actually did it correctly. So when we plug it back into the equation, we got 8 plus 2 times 8, which does equal 24. Then we got the opposite of 8, plus 8, which equals 0. And so that checked out also. So our final answer was the coordinate 8, 8. And last but not least, we have another problem, which we once more need to solve by elimination. Now, notice already arranged in columns, so step 1 is done. However, if we're looking at our coefficients, if we're studying them, notice we have a 4 and a 10, and we have a negative 6 and a 7. And so what I'm going to do is, when I get those opposite coefficients, I notice that my y's are already opposite. I have negative 6y, and then I have a positive 7y. And so I'm going to go ahead and multiply to make my y's opposites. And so 6 and 7, the first number they both have in common, is actually 42. And so what's going to happen is I'm going to have to multiply this top equation by 7 and this bottom equation by 6. Because that's going to make my y a negative 42y here and a positive 42y down there. So let's see what happens when we multiply every term by 7 in the top equation and every term by 6 in the bottom equation. We end up with 28x minus 42y equals minus 42. Then in the bottom equation, we end up with a 60x plus 42y equals a minus 24. And so we did steps 1, 2, and 3. So now we're on to step 4, where we want to add our equations together. Since we have opposites, if you don't notice, they're right here on my y's. So when we add our equations together, we should end up with only x's. So I have 28x plus 60x, which is 88x. Y's disappeared. And then on the other side, it equals a negative 66. From here, we need to solve for x, so we're going to divide both sides by 88. Divide by 88. And x equals a negative 3/4 when you simplify. Notice I did not leave that as negative 66 over 88 or even as 6/8. I simplified all the way down as far as I can to negative 3/4. From here, we're on to the substitute to find the other variable. So I'm going to always just plug it into the top equation. You can choose either. I just like to always use the top one. So I have 4, x is now negative 3/4, minus 6 times y equals a minus 6. 4 times negative 3/4 is just negative 3, minus 6y equals negative 6. So minus 6y equals negative 3 when you add 3 to both sides. Then divide by negative 6 and you get y equals a positive 1/2. However, from here we always need to check. So we think currently our answer should be negative 3/4, 1/2. However, we need to check just to make sure there weren't any errors made. So it should work out in both equations when we plug it back in. And at this stage, you always want to use the original equations just so there's less chance for error. Because if you did math wrong down here somewhere, that could screw up everything else. So if you use the original equations, there's less chance for an error being made. And so when we check, we get 4 times negative 3/4 minus 6 times 1/2. Negative 3 minus 3, that does equal a negative 6. Then we have 10 times negative 3/4 plus 7 times 1/2, where we get, if we solve, that becomes negative 15/2 plus 7/2, negative 15 plus 7, negative 8/2, which yes, it does equal a negative 4. So after checking, we can see that we did our math correctly. And so our final answer is for sure negative 3/4, 1/2.